Okie dokes. This is a Euclidean geometry question. Let us read the information together as well as analyze the diagram together. Now let us start by reading the information. It says in the diagram, DE is a tangent to the circle at E, and the DFG is a secant intersecting the circle at F and G. DE is equals to EF is equals to FG. H is a point on EG such that FH is parallel to DE. Now we are also given the diagram and the information, but now this is what is important, guys. Listen. In a diagram, we have line DE, but in the information, we are told that line D is a tangent. That means it is a tangent. So if it was not given that D is a tangent, it wasn't a tangent unless if you have proven it that it is a tangent. So in Euclidean geometry, you do not assume unless if you are told that whatever that you see it is if it is only told, or if you have only proven it to be it. Now listen, this is what is happening, guys. This is what I always tell you to do. If you are told that this line like this, it is a tangent, there are a few things that you have to think of from the basics that you have learned. Now, if you're told that D is a tangent, what are you thinking of? You are thinking of if there is a center and there is a line that is drawn from the center to the tangent. Think of axiom 7, whereby a line that is drawn from center to a tangent, they always act perpendicular. Or if you are told that line it is a tangent, what do you have to think of? You have to think of Tancourt theorem, okay, which is one of the theorems that you have learned in grade 11. So in this case, we do not have center. That means we can just only think of Tancourt theorem because we are told that D is a tangent. Now with Tancourt theorem, what are you thinking of? Look, Tancourt theorem, you're supposed to have chords that makes a triangle, and the vertices of that triangle are supposed to be at the circumference of the circle. Now this is a tangent, and then here we have a chord, we also have a chord, but these three chords, they make up a triangle whereby the vertices of that triangle are at the circumference of the circle. Now for the fact that this is a tangent, then we can think of a Tancourt theorem, where we're going to say this is angle E, okay, but it is angle E1, whereby we can simply just say angle E1 is equals to the magnitude of this angle, which is angle G. Okay, why? Because it's a Tancourt theorem whereby this angle is equals to this. Now I am going through this diagram before I solve the questions so that the questions can be simple for us. Okay, so meaning angle E1 is equals to angle G. It's a Tancourt theorem. And then again, guys, from the information we were told that DE is equals to EF is equals to FG. Again, on the diagram it is also indicated that FG is equals to EF, or you can just say FE. Okay, FG is equals to FE. It is indicated on the diagram, but look, these two sides, they are in a triangle. Now for the fact that these two opposite sides are equal in magnitude, that means the base angles in that triangle, that means the base angles are also equal. Okay, that means angle E2 is equals to angle G because two opposite sides of that triangle are equal. Again, guys, we were also given from the information that FH is parallel to DE. FH is parallel to DE. Guys, again, when you are told that the lines are parallel, these are the things that you need to think of, okay? From grade 11 or from the other grades, you have to think of alternating angles within the parallel lines corresponding as well as co-interior angles. That's what you have to think of, okay? Again, here in grade 12, you have to think of, look at this triangle, DGA, DGE. These two sides are parallel, meaning these two sides, they do what? They cut these two sides into the same or equal proportion. Okay, now for the fact that these two lines are parallel, angle E1 is equals to angle F2. Okay, angle E1 is equals to angle F2. Look, this is a Z. Okay, this is a Z whereby these two angles are equal in magnitude because they are within the parallel lines. Now what do we call this line? What do we call these angles? We say they alternate. Okay, that's the reason why these two angles are equal in magnitude. They are in a Z shape and within the parallel lines, that means these two angles are alternating angles. So that is the only important information that you can even think of corresponding angles, whereby this angle is equals to the sum of E2 and E1, because these two lines are parallel. Okay, those are the most important basics that you need to understand before solving the questions. But now, because we have seen a lot from the diagram and from the information, let us try to tackle the questions. Okay, let us start by reading the first question. Now 10.2.1, it says determine, giving reasons, three angles each equal to D angle EF, meaning we want three angles each equal to D angle EF. Okay, where is D angle EF? D angle EF, in this case it's angle E1. Okay, now we want three other angles that are equals to angle E1, in this case, which is D angle EF. We want three other angles. Before we came into questions, we have already talked about the diagram. We have already analyzed the diagram. Now let's have a look. D angle EF is equals to angle G, and we said it's Tancourt theorem. And then again, look, we said that from this triangle we have two opposite sides which are equal. That means their base angles, they are also going to be equal. Now angle G, it is equals to angle E2. Now for a fact that angle E2 is equals to angle G, remember angle G is equals to E1. That means angle E2 is also equals to angle E1, which is D angle EF. Okay, and then again, remember we have parallel lines, and we say that angle E1, which is D angle EF, is equals to angle F2. Why? Those are the alternating angles within the parallel lines. That's how we are going to determine the magnitudes of other three angles that are equals to D angle EF. But how are we going to write it in exam or in whatever classwork? Now this is how you are going to write it. So that we are doing 10.2.1. okay, we are doing 10.2.1. now let us start. Now angle what? Angle F2. Angle F2 is equals to D angle EF. And what is the reason? Alternating angles, since FH is parallel to DE. The statement and the reason. Why are you saying F2 is equals to E1? Why are we saying F2 is equals to E1? Because of the alternating angles within the parallel lines, and you mentioned that your lines are parallel. Okay, that's the first angle that is equals to D angle EF. Now what is the second angle? The second angle is angle G. Angle G is equals to D angle EF. Okay, angle G is equals to D angle EF, which is E1. Remember Tancourt theorem, we have already talked about that. So our reason here would be Tancourt. Okay, you just write Tancourt, or you can simply write Tancourt theorem. And therefore that will be a second angle which is equals to D angle EF. And then what is the third angle? Now this is the third angle. Look, remember angle G is equals to angle E2. Equal opposite sides, equal base angles. Okay, so in this case angle E2 is equals to angle G. Okay, why angle E2 is equals to angle G? This is our reason. Equal opposite sides, meaning we have equal base angles. Okay, now for a fact that the G is equals to E2, that means angle E2 is also equals to, remember we have already determined that the G is equals to DEF. That means angle E2 also is equals to D angle EF, because both of them, they are equals to G. Okay, and therefore this will be three other angles that are equals to D angle EF, meaning we have F2, we have angle G, and then we have angle E2. All of these three angles, they are equals to D angle EF. Now let's move on to the next question. It says 2.2.2, prove that triangle DEF is similar to triangle DGE. Now when we prove a similarity, guys, it depends what is given. In this case, we are going to deal with the angles. Okay, when we prove the similarity, we are talking about the equiangular triangles, meaning we are going to prove that the interior angles of two different triangles, they are the same or they are equal in magnitude, but the sides of two similar triangles are not equal. We say they have the same proportion. Okay, they have same proportionality. Now let us go through our diagram to look for these triangles, meaning for triangle DEF and triangle DGE. Now in our diagram, triangle DEF, can we see it? And then we have triangle DGE. We are going to prove similarity, meaning we are going to prove the equality of all angles in these two triangles. Now let us talk about triangle DEF. In triangle DEF, we have this angle. Okay, this angle is called angle D. Now angle, you know what I like to do now to make things much more easier? This is what I like to do. I'm going to draw these triangles. Okay, I'm going to draw these triangles separately here. So we have this triangle. This triangle is called triangle. This is angle D. This is angle F1. This is angle E1, and then we have this other triangle which is DGE. It's a bigger triangle. It's a little bit bigger. So here we have D, here we have G, and here we have E. Remember, we were asked to prove similarity between these two triangles. I just extracted these triangles from this diagram, okay, so that they do not confuse us. So this is DEF, and this is DGE, okay. Now let's talk about those two triangles. Now let's talk about this angle of triangle DEF. This angle, which is angle D, is the same as this angle also, which is also called angle D in this bigger triangle. Okay, this triangle for this angle for this triangle, it is the same as this angle for this bigger triangle because it's a common angle. Okay, it's a common angle. And the other angle in these two triangles which are equal is angle E1. Remember, angle E1 is the same as angle G. We have already proven it, or you can just simply say it's a tan chord theorem, meaning angle E1 is equals to angle G, which is a tan chord theorem, and therefore angle F1 is the same as angle E1, which is the third remaining angles of triangles. Okay, now how are we going to write this in exam? So now we are moving to 10.2.2. we are going to say we are proving similarity between these two triangles. We are going to say in triangle DEF and triangle DGE, we are going to say F angle DE is the same as G angle DE. Okay, F angle DE is the same as G angle DE. And then what is our reason? What is the reason? It's common. We are talking about the common angles. Okay, and then again in the very same triangle, we are going to say angle E1 is the same as angle E1. Remember, in this triangle is the same as angle G in the bigger triangle. It's the same as angle G. And what is our reason? Tan chord theorem, or you can just say proven. Okay, because we have already proven it up there. You see, so angle E1 is equals to angle G. That means angle F1 is equals to this bigger angle. Okay, it's equals to this bigger angle, for a bigger triangle. We're going to say those are the third remaining angles in a triangle, and then we are going to say angle F1 is equals to D angle EG, the third remaining angles of triangle. Okay, that will be our reason. And then we can say now triangle DEF is similar to triangle DGE, and what is our reason? It's angle. Now we managed to prove a similarity between these two triangles. Remember, I have already extracted those angles that we have just proved similarity in them. Okay, it was this smaller triangle which is DFE as well as DGE. Okay, just extracted those angles here because we're going to need them later on. Now let us move on to, this was 10.2.2a, and then we move on to 10.2.2b. 10.2.2b. Now 10.2.2b, it says prove that angle D is equals to 72 for 5 marks. Okay, we are going to prove that this angle is equals to 72. Okay, we are going to prove that this angle, which is D, is equals to 72 degrees. Damn. Now, how are we going to prove that this is 72 degrees? Remember, we are not given any magnitude of any angle, so we have to figure it all out, how to determine that this angle is equals to 72 degrees. Now, this is what we are going to do for 5 marks. Again, we are looking for angle D, but now where is angle D located? Angle D is located in triangle DFE, and remember, in this triangle, we have already talked about this triangle. We said this triangle is similar to the bigger triangle, which was the GE. And again, angle D, it is also on that bigger triangle. So angle D is located into two triangles. Meaning this is angle D. This is where angle D is located, in this smaller triangle and this bigger triangle. So we need to determine the magnitude of angle D, that it is equals to 72. We need to prove that. Okay, meaning actually we are required to prove that angle D is equals to 72 degrees. That's what we are required to prove. Okay, now let us start. Look, in triangle DEF, angle F1 and angle D are equal. Why? Because the two opposite sides are equal. That means the base angles are going to be equal. Okay, look, we are going to say angle D is equals to angle F1. Why am I saying that? Because we have equal opposite sides. That means equal base angles. Okay, angle F1 is equals to angle D. Now we know that sum of angles in a triangle, they add up to 180 degrees, meaning angle D plus angle F1 plus E1 is equals to 180 degrees. Meaning I'm just going to say twice angle D plus angle F1 is equals to 180 degrees. What's my reason? Sum of angles in triangle. Okay, why did I roll twice? Because remember, F1 plus D. Remember, F1, I can express F1 as D because they are equal. So it's like D plus D, it's 2D. Hence why I said twice D here. Okay, and therefore this, and I'm going to make angle F1 subject of the formula. So I'm just going to say angle F1 is equals to 180 degrees. I transpose this one to the other side. It's negative 2 angle D. Okay, and therefore this will be my equation number 1. So now I'm done with triangle DEF, whereby I determined the magnitude of angle D in terms of what? I determined the magnitude of angle E1 in terms of D, which is what I'm looking for. So I have two unknowns from this triangle, which is DEF. Now I'm going to deal with the bigger triangle. I'm going to deal with triangle DEG. Okay, so now let us move through that triangle. Now this is what I'm going to do. I'm going to say intra-angle DGE. Guys, remember angle G we said is equals to angle E1, meaning this is the same as angle E1 because I have proven it by Tan-Court theorem. Do you still remember? So in this bigger triangle, I'm going to say angle D plus angle G plus this bigger angle, which is E1 plus E2. Remember, E1 and E2, they are also equal in magnitude. So I am also going to call angle E1 angle E2 angle E1 because they are equal. Okay, so this angle is actually twice E1 because this is E1 plus E1, it's 2E1, and then this is only E1, and that will be angle D. So I'm going to say angle D, which is this angle, plus angle E1, which is G, okay, plus angle E1 plus twice angle E1. Remember, I have explained, plus twice angle E1 is equals to 180 degrees. And what will be my reason? Sum of angles in triangle. Okay, sum of angles in triangle. And therefore E1 plus E1, I have angle D plus E1 plus 2E1, it's 3 angle E1 is equals to 180 degrees. Now remember, I made angle E1, not F. I made angle E1 subject to the formula, meaning wherever I see E1, I'm going to write this here in this equation. So here I have angle D plus 3 times E1 in this case equals to how much? 180 degrees minus 2 angle D is equals to 180 degrees. And therefore, let's work it out. So we have angle D plus 3 multiplied by 180, it's supposed to be 540 degrees. 3 multiplied by negative 2D, it's negative 6 angle D is equals to 180 degrees. And therefore I'm going to transpose 540 to the other side. This and this is negative 5 angle D is equals to, here we have how much? Negative 360 degrees when I transpose 540 to the other side. And therefore I divide both sides by negative 5, and therefore angle D is equals to 72 degrees. Okay, it's equals to 72 degrees. Now I want us to move on to question number 10.2.3. okay, now sorry about that. 10.2.3, let us read 10.2.3. It says, if it is further given that df is equals to k units, df is equals to k units, and fg is equals to 2 units, fg is equals to 2 units, prove that k squared plus 2k is equals to 4. Okay, we need to prove that. Now guys, look, this is what we are required to prove. But let me ask you this simple question. Where is k units located? It's located on this side, which is side DF, and side DF is on which triangle? Side DF is on triangle DEF. And remember, we have already talked about this triangle. Do you still remember? DF, where is k units, is located on triangle DEF, and we have already talked about this triangle. So meaning here it's k. Okay, we have already talked about this triangle when we proved that this triangle is similar to this triangle. Okay, and then where is FG located? Remember, these were given from the information. This is where FG is located. But now I want you to understand this. Now for the fact that I talked about this side, let's compare this triangle with this triangle in terms of their sides. Okay, so now we were not given DG or whatever side from this in this triangle, but we were given EFFG. Now DF and FG, they make up this side, this bigger side of this triangle, which is side DG, meaning DG is actually equals to K plus 2. Okay, meaning this side in this case is going to be equals to how much? K plus 2 units. Do you see it? Now look, for a fact that we proved a similarity between these two sides, between these two triangles, that means these two triangles, they are sides. The sides of these triangles are in the same proportion because they are similar to one another. So we're going to use proportionality theorem to prove this, which is what which was required from us to do. Okay, so now this will be 10.2.3. so we're going to say 10.2.3. we are actually required to prove that k squared plus 2k is equals to 4. We are actually required to prove this equation. Okay, now how are we going to prove it? We are going to use those two triangles. Now guys, remember, I gotta say to us, FG is equals to FE is also equals to DE. That means this is 2 units. That means there it is also 2 units, and there it is also 2 units, because they are equal in magnitude and it has been given to us. So now this is what you are going to do. You are going to say DE is equals to FG given. That means DE is also equals to 2 units, and therefore you go to your diagrams. So remember, this is side DE. Okay, this is side DE. It's 2. This is also side EE. It's 2. It's a common side for these two triangles that we have proven similarity in there. Now look, this is what we are going to do. Okay, now for the fact that these sides are in the same proportion. Oh, by the way, and this here we also have 2. Don't forget that. Also here we have 2, because they say that this side is equals to this side, it is also equals to that side. Okay, so now according to proportional theorem, this is what we have proven. This is what we have proved. Okay, these two are similar. Okay, now check, let us use proportionality theorem. Okay, so we are going to say the DE over DE. Let us agree DE is opposite to this angle, which is angle X. Now let's go to that triangle and find the side also which is opposite to X. Okay, so the side which is opposite to X in this case is DG, meaning we're going to say DE, which is opposite to X, over DG, which is also opposite to X, is equals to DF, which is opposite to this angle, which has 2 bars. Okay, DF over, let us move to that triangle and see the same, the E1 is the same as G1, and they have 2 bars. So that means DE is opposite to this angle. In this triangle, DE is also opposite to the very same angle. Okay, here it's DF, it's opposite to angle E1, and then here it's DE, which is opposite to angle G. That means it's DF over DE, and therefore we cross multiply. We are going to say this multiply by that, it's DE squared. This multiply by that, it's DG multiply by DF, and therefore let us substitute. What is DE? DE is 2, so we have 2 to the power of 2, and therefore this is DG. DG is K plus 2, and then what is DF? DF is K, therefore 2 to the power of 2 is 4, and therefore K multiplied by K, it's K squared. K multiplied by 2, it's 2K, and therefore remember, this is what we were required to prove from the question, and therefore we managed to prove it. Okay, this was 10.2.3. remember 10.2.3, it said to us, if it is further given that DF is equals to K units, FG is equals to 2 units, prove this equation, K squared plus 2K is equals to 4. And this is what we managed to prove. And then the last question, 10.2.4. 10.2.4, it says, determine given reasons the ratio of GH of G. But remember, guys, before I forget, I get here we use a proportionality theorem. You just gonna say similar triangles. Okay, that will be your reason, similar triangles. Now 10.2.4, it says determine given reasons the ratio of GH over GE, meaning we want the ratio of GH over GE. That's what we are looking for. Okay, now let us go in our diagram to look for these two sides, GH and GH. GH, not G, GH and GE, GH and GE, GH and GE. Okay, GH and GE. So look, GH over GH over GE is the same as GF over GD. Why? Because these sides are parallel, meaning these sides cuts these two sides into same proportion. So GH over GE is the same as GF over GD. It's the same as GF over GD. What is our reason? Proportional theorem. Okay, theorem, since FH is parallel to DE. Okay, now what is GF? GF in this case is equals to 2 over GD in this case. GD is in this case equals to K plus 2. And then we are now done.